Hi everyone, welcome back to my channel. In this video we'll prove that uh, given that sine of uh, 105 minus sine of minus 15 over cosine of 115 plus cosine of minus 15 is equal to the r of root 3, then r is equal to 1. So uh, what do we need to know? First of all, when we look at this expression, we can see that these are kind of trigonometric functions and kind of compound can be expressed into compound angles. So what we have to do is to recall all the formulas that can help us to deal with compound angles. So and subtraction, addition of all these trigonometric functions can be recalled. So in this case, let's try to recall that if you have sine of A minus sine of B, this is equal to 2 cosine of A plus B over 2, then sine of A minus B over 2. And again, you can recall that if you have cosine of A plus cosine of B, this is equal to 2 cosine of A plus B over 2, then cosine of A minus B over 2. So in this case, if we relate this into that, we can say that we can say our A is equal to 105 and then our B is equal to minus 15. All right, and so this means that A plus B divided by 2 is equal to this plus that, which will take us to I think 90, and then 90 divided by 2, that goes to 45 degrees. And then you can see that A minus B, so this minus that gives us 120, and then divide by 2. So basically what we have, A minus B over 2 is equal to basically is equal to 60, because this is 105 minus 15, that's 120 over 2. So the reason why we are getting first of all these two parts is that we need them to substitute them here in all these angles, and this is something we are doing without any use of calculators. Okay, so when you have this, then it means that we can go up there and simplify that sine of 105 minus sine of minus 15. However, you could also bring this right here. It would be the same thing, but you can just keep it as it is. This gives us 2 cosine of this expression, which is this, now 45 degrees, sine of that, which is this, so this is equal to sine of 60. And again, you can also recall this lower part, which is in this form, that cosine of 105 degrees plus cosine of minus 15, though cosine of a negative angle is the same as a positive angle, but we will not ignore that. We can see that this can be simplified as that, or expanded as that, or added. So this is equal to cosine of A plus B over 2, which is already 45 right here, then cosine of A minus B, which is also here as 60. So now when we have this, then this means that we are now able to go up here and substitute in. So this now becomes substitution of that, which is 2 cosine of 45 degrees, sine of 60 degrees, everything over 2 cosine of 45 degrees and cosine of 60 degrees. Observe that this can cancel, and then all we have we are left with is the sine of 60 over cosine of 60, which is basically tan of 60. So we have this over cosine of 60. We could even simplify these two as well, but we can try to simplify that further to tan of 60. So now this is what we have. Then we need to ask ourselves, how do we find this without calculators? If you recall from the triangle, that if this is 90, this is 60 degrees, and this is 30 degrees, this is 2, this is 1, and then this is root 3. So from this you can see that tan of 60 is equal to opposite over adjacent. This is the adjacent of that angle, this is the opposite of that angle, so it's root 3 over the adjacent, which is 1. So basically, which means that this angle here, tan of 60, is the same as root 3. So when you go back in the problem, you can see that sine of 105 degrees minus sine of minus 15 degrees, everything over cosine of 105 degrees plus cosine of minus 15 degrees is reducing to this, and which is equal to basically root 3. So from what we are given, we can see that we are given that it should be in this term, and so our answer is in this form. So all we need to compare is, we are comparing our root of 3, and this is equal to root of 3. So basically, which means that our r is equal to 1. So this is what is required to be proved right here. Yeah, thank you so much. Please consider subscribing to support this channel.